So there's three things that are very attractive for near-Earth objects, near-Earth asteroids, right? When you have the science objectives, you have the planetary defense objectives, and then you have the in situ resource utilization objectives. All three things make near-Earth asteroids very, very attractive, near-Earth objects, as you will, very attractive. So in order to accomplish those goals, and if you want to actually use them as stepping stones to get out to Mars and further human exploration, there's several things you need to do first. One is you need to learn how to operate in microgravity situations, and we're doing that with ISS, International Space Station. We have further plans to use the International Space Station as a microgravity test bed to enable our extravehicular activities, EVA, around these small objects. Maybe even learn how to interact and anchor to them, and maybe even extract material from representative types of materials that you could put in station in a glove box. So using ISS as the first linchpin is key. Then we'd probably use robotic spacecraft, robotic precursors. We'd go and we'd actually go to the targets of choice, of interest, that we could get to with our human capability spacecraft. Even before that, though, we may even actually, as one of those robotic precursors, employ a space-based NEO, Near-Earth Object Survey Telescope, which would help find all the objects that we need to find. It's much easier to do that from space than the ground. Identify those of interest, characterize them to a certain extent, and pick out some targets. Then we'd actually take some robotic precursor spacecraft designed to study those targets in situ, in place. They would rendezvous and stay with them for a number of years and study them in terms of the physical characteristics that are essential that we need to know about for human exploration. So for instance, what's the rotation rate? What's the composition? Is there an active surface? All those things that would be first and foremost responsible for human safety and spacecraft safety, right? If you can't operate around it, you can't interact with it, that doesn't make it a very good target. So doing that, you'd have that precursor there. Then, after you've validated the target and everything looks okay and this is a good destination to go to, then you follow up with humans. And we're thinking maybe between 3 and 5 years between when the precursor gets to the first NEA, validates it as a target, to when the human mission is launched. Then the humans go, do all the great scientific, planetary defense, and resource utilization objectives, get samples, and then come back.